Hello guys, it is research series, and in this session I want to teach you MANOVA, or multivariate analysis of variances, and when you can use MANOVA. MANOVA is used to measure the effect of a qualitative variable, for example headache severity in this study, on several quantitative features, for example anxiety score and depression score, which both of them are quantitative. There are several conditions before performing MANOVA. First of all, your quantitative features must have a normal distribution. Second, there must be significant correlation between your quantitative features, depression and anxiety scores, and finally you must have a homogeneity of variances before performing a test. First of all, I start with the normality test, and I choose the descriptive statistics, then explore, and I send depression score and anxiety score into dependent list and headache into factor list. Headache is my grouping variable, and then I choose statistics, and I can choose descriptive statistics. I choose plots, and I select histogram and normality plots with test, and then continue. I click OK. There are several tests to measure the normality of your datasets. First of all, you can look at the skewness value. A skewness value of between -1 to +1, between -1 and +1 is considered normal distribution. As you can see, skewness is less than 1, and in patients who had never headache, and here it is again less than -1, and again here, and here, or here. You can see in all subgroups of headache, and across the whole group, both depression score and anxiety score have a normal distribution pattern. There are also Kolmogorov, Smirnov, and Shapirovic tests, which can measure the normality. Based on these values, just the anxiety in those who had never headache might have a normal distribution, but as the skewness value showed it has a normal distribution, you need to pay attention to other tests and have a conclusion. My histogram shows that in those with those who had never headache have a normal depression score pattern, and similar pattern can be observed across other subgroups. Also, Steven Leaf chart shows the same normal distribution pattern, with most of data located in the middle. QQ plot also shows that all dots are located on the line, showing a normal distribution pattern, and I can see the similar pattern in all subgroups. Also, for the anxiety score, a similar pattern of normal distribution can be observed, and the QQ plot also certifies that there is a normal distribution pattern. So I can conclude that I have a normal distribution pattern in both anxiety score and depression score. Then I want to check the homogeneity of variances and the correlation between depression score and anxiety score. I choose analysis and then correlate and bivariate to measure the correlation between depression score and anxiety score. I choose the Pearson test because my dataset has normal distribution. For measuring the correlation between datasets without normal distribution, you can choose Spearman test. I then click OK, and as you see, there is a robust correlation between depression score and anxiety score, and my p-value is also significant. You should remember this number. It is important for us in the later stages. And I close this window, and I then ran the final analysis. I choose analyze, and then general linear model, and then multivariate. I send the depression score and anxiety score here in independent variables, and the grouping variable, I mean the headache, in the fixed factor. I then choose the post hoc analysis. If I send the pain into post hoc tests, for the options will be activated, and I choose bone frowny test for post hoc analysis, and then I choose continue. I also choose options and choose homogeneity tests to measure the homogeneity of variances, and then I click OK. The boxes test measures the homogeneity of variances, and the p-value is more than 500, showing that my dataset has homogeneous variances. And then I have a table named multivariate tests. I can see here there are several p-values, and I want to choose among them. If you remember, I told you that the correlation coefficient in your correlation analysis is important for you. It is used here if your correlation coefficient in the Pearson test is between 0.5 to 0.7, then you can choose the p-value of Wick's lambda test, which is significant. If there is a very high level of correlation, I mean a correlation coefficient of more than 0.7, you can choose the Roy's largest roots, which similarly shows a significant association in this study. So as my correlation coefficient was more than 0.7, I choose Roy's largest roots test, and I can conclude that there is a significant association between headache and anxiety score, or the depression score. Now I need to know which one of the features, which one of the outcomes, I mean the anxiety score and the depression score have a significant correlation, significant association with the headache, I use this table, tests of between subjects effects, and now I can see that headache is significantly associated with both anxiety and depression. Then I need to run the post hoc tests and measure which one of the subgroups are significantly associated. As you can see here, for anxiety, those who had never headache are significantly different from those who had often headache, and we can also see there are asterisks here showing the significant associations. For example, you can see that for depression score, patients who sometimes had headache are significantly different from patients who often had headache. You can also observe the p-values here. MANOVA can decrease the first type error. For example, if you use one-way ANOVA for running two tests separately for measuring the effect of headache on anxiety score and on depression score, then you are exposed to double error. For example, you are committing first type error, I mean alpha error, for each one of these tests, but when you are using MANOVA, you are just running one test and it can decrease the first type error, which is very important in the statistical analysis. If you enjoyed this video, please don't forget to like, subscribe and comment. See you soon.